Okay, YouTube, in this video we're going to define the magnitude of a vector. We know that it is the length of a vector, but how we find it given some vector v, okay? So first things first, when we talk about the magnitude of a vector, the length of a vector, we represent it by this double bar around our lowercase letter that represents this vector here. So whenever you notice that we talk about the length of a vector, we say that it is this double bar v. And I'm going to write a line above this to indicate that it's a vector. But this is its magnitude, or in other words, this is the length of the vector, okay? Another way to write this would be if we know the component form of v is some ab, essentially we could say that it is the magnitude of the component form of this vector, because our vector could be described using this as its terminal point, but we could say that this would also indicate its length, since v and a comma b in terms of these cusps right here in component form are the same thing. So you'll notice that I've given a formula down here. We say that the magnitude of v is really just the square root of a squared plus b squared, where we have the x component and the y component of our vector. And so given some vector that's already in component form basically implies that it starts at the origin and goes in any direction. So let's say, for instance, here I have this vector and it goes out to here, and we say that it stops at this point right here, and we already have been told that if this is the vector v, then we know that this point right here is this point a comma b. This was told to us in its component form. It starts at the origin, terminates right here. The way that we would find the distance right here would be to conceive of this as being a Pythagorean type situation. So we would know that since we know this point on the terminal side, we know that the x component is b and the y component, or sorry, the x component is a, y component is b. Then we could just use Pythagoras. So we would say a squared plus b squared, or x component squared plus y component squared, is equal to the magnitude of this vector squared. And so since we just want the magnitude of this vector, essentially we would take the square root of both sides. It's just distance formula. And we get that the magnitude of v is what you see listed on the left there, which is the square root of x component squared plus y component squared. So really all we need are these two values right here, these a and b values, or some x and some y where it terminates. And then we could go find the magnitude of this vector. So let's say, for instance, let's say I had a vector and our vector is 5, 3. You know, we could sketch this out. This would be some vector that goes 5 to the right, 1, 2, 3, 4, 5, and up 3, and terminates at the point 5, 3. So we would say that here's our vector right here. And since we know that this is the point 5, 3, I'm all about drawing a picture. We could say that really we know the height is 3 and this is 5. So we want the magnitude of this vector here, and let's say that this is some vector u. So we say u is this right here. To find the magnitude of u then, according to our formula, all we need are these two components on our vector. And so essentially we could say that really the magnitude of this vector u would be equal to the square root of 5 squared plus 3 squared. And so we would get the magnitude of u is equal to the square root of 25 plus 9, which is the square root of 34. And I do believe that that's 2 times 17, and those are both prime. So we're not going to break this down any further. So we would say that this is the length of the vector right there. And just to go to show, I did sketch this out here on our plane. And you can see that in component form, it goes right 5, up 3. So we've got a vertical component of 3, horizontal component of 5. But if we were to ask, say, for a distance on this, we say distance from A to B here, it gives us about 5.83. And if we were to take the actual square root of 34, so we say 34, the root of that, we say that we get that 5.83 figure right there. So that is how you find the length of a vector in component form. It is the square root of the sum of the squares of its components. Cheers.